Yeah, my name is Reuven, and I teach Python and pandas for a living. So I've been in business since 1995. The good news is I have a picture from back then when I started working. But now is the age of AI, so I was able to enhance it somewhat. So basically, yeah, I teach companies all around the world. I have my own learning platform now at lernerpython.com, courses, exercises, I do office hours. As I like to say, if you are the person at work that everyone is bugging with Python questions, they can bug me. I really enjoy it. I have a newsletter called Better Developers, where I put out a new article about Python every week. I have a newsletter called Bamboo Weekly, where every week I pose pandas questions based on current events. Wednesdays, new questions. Thursdays, full detailed answers. You can download the Jupyter Notebook if you want to get more practice with pandas and not have your boss look down your neck while you're trying to solve things. I love this. And I also have a YouTube channel. Also, I'm here at EuroPython. I have stickers. I have a sticker marked Snacks Exchange. I thought this meant that people would stop you and ask you for snacks. This morning I found out, no, there's a table where you should put them. So please take the cakes that I brought, because I brought a lot of them and they're very good. Okay, on to our actual subject. What happens when we assign? And it seems really simple and obvious and straightforward, because from the first moment that we start programming in Python, we assign to variables, x equals 100. But already, I can tell you from teaching newbies to programming, there is already a problem there. And the problem is, we're using the equal sign. And they are used to the equal sign from mathematics, where the thing on the left and the thing on the right should balance. And if you say x equals x plus 1, there is a mathematical problem with that. And that's because we're using that same symbol, but it doesn't mean the same thing. It means that we are assigning. But what does assignment really mean? Well, basically, very simply, we're going to go much deeper than this. It means evaluate the right side and then assign that value to the left side, to the variable on the left. All right? And it's really important to remember that it's right before left when we do assignment. First, the thing on the right is evaluated, and whatever we get back is then assigned. So if I say x equals 75 plus 25, really when the assignment happens, it's already become 100, because as far as the assignment is concerned, oh yeah, that addition, that happened long, long ago. Another thing that people don't quite understand is how variables are how variables work. So here is what is not happening. There's a little place in memory marked x, and we stick the 100 in it. Now, why would we think this, right? Well, the first thing is because it's easy to understand, right? And it's a good metaphor that many instructors use when they talk about programming. Oh, when we assign a value to a variable, what we're really doing is sticking it in a box marked x or whatever it would be. The other thing is, there are some poor, sad souls in the world who have programmed in C. And for them, this actually makes sense. For the C programmers in the crowd, I'll talk slowly. No, anyway, basically, the idea in C is that a variable is an alias to a location in memory. And when I want to assign to a variable, I am sticking that value into that place in memory. And that's one of the reasons why in C and other such languages you have to declare your variables so you'll know how much space there is and how much space we need to stick our things in. Now, I'm a huge, huge fan of the Python tutor site, pythontutor.com. It is amazing, and it visualizes Python code. I use this in my courses all the time. The problem is that the Python tutor, by default, also helps people or sort of encourages people to have this mental model. Because if I say x equals 100, you can see here on the right, it says x and 100 right next to it. The thing is, Python is not like this. A variable in Python refers to a value. It doesn't refer to a location in memory. It doesn't refer ever to another variable. And here's the other thing. Values are anonymous. There's no inherent name to a value. We give it a name, or multiple names, when we assign a variable to that value. And one metaphor I like to use is, if values are nouns, then variables are pronouns. They refer to a value. And of course, we can sort of assign a variable to a new value as we need. Now, if I want, I can tell the Python tutor, hey, why don't you show this more realistically? I choose this from the menu here, render all objects on the heap, Python and Java, and now it actually shows things the way that Python works and the way that we should think about it. Right? So x is on the left, it's a variable. Our object, our value 100 is an integer. Notice that every value knows what type it is. The type is not on the variable. The type is on the value. So it knows it's an integer, and x is referring to it. Now, people often have the sort of idea that Python is an interpreted language, and that's sort of true, but sort of not. It's compiled into byte codes, into opcodes, and then those byte codes are interpreted. And I love using the dis module in the standard library to take code apart and understand what's really going on. We're going to be doing it a lot here today. So if I say x equals 100, and I turn that into byte code, what's really happening behind the scenes? So we're going to ignore the resume stuff, but then basically it's loading up the constant 100, it gets that value, and then it says store name. That is how Python assigns to a variable. We have the name there on the right, x, which is in the 0th place, the 0 index in the well, anyway, we won't get into too much. We'll get into that later, but parameters, and we store it there. Yeah, but what really happens when we assign? Right, because people sort of, that's a nice and easy way to think about it. Oh yes, I say x equals 100, as the byte code, it stores to there. But people get really confused. So for example, if I say x equals 100 and y equals x, then x equals 200, what will y be? Well, in that first line, I say variable x refers to the integer 100. We've seen that. And then I say y equals x. This does not, absolutely positively does not mean that y is now sort of following x. It means that y refers to whatever x's value is, because again, we're evaluating the right side, getting a value, 100, and now y refers to 100 as well. So when we say x equals 200, great, that doesn't affect y, and thus y will print 100. And if we put this in the Python tutor, we can see this visually. X is 100, and then we say y is 100. Now we have two variables referring to the same value. And when we say x equals 200, yeah, x is now referring to 200, but y continues to be there, and thus when we print y, sure enough, it's going to print 100. Now the equal sign, the assignment operator, is not the only way to assign variables. We can also assign variables with some pretty common keywords. Def assigns a function object to a variable. Class assigns a class object to a variable, and import assigns a module object to a variable. All of these, we have a single namespace in Python for all of these things, for data and for functions and for classes, and so these all assign. We're not going to go into these, but you should just know that these are also doing assignment. So far we've been talking about global variables, and Python keeps track of global variables in a dictionary, in a dict, which makes sense because we have names and we have values. By the way, if you ever wondered why or how can it be that we can store any value we want in a Python dict, that's because Python is storing all of our values in a dict, so it must work. And if you ever want to mess around with things, you can use the globals built in, and it returns a dictionary that gives you all of those globals. You can even assign to it if you want, if you don't want friends at work. The thing is, global variables can get really messy, right? If one part of my program changes a global, that's going to be affecting the rest of the parts of my program. And so we like to use functions. And in a function, I have local variables. Very important to remember that the scoping for a function or the scoping of local variables only happens in a function. If I have indentation for an if, a for, a while, a with, none of that affects the scoping at all. None of that gives me local variables. Those variables that I define there are still global. They still affect what's going on elsewhere. But if you do have a function, then yeah, you do have local variables. How do we declare a variable to be local? Well, the Python bytecode compiler notices that we are assigning to a variable inside of our function, and it says, aha, I'm going to keep track of this. This is a local variable. And it stores a tuple of those variable names in the function object. So if I have a function here, my sum, a and b, total equals a plus b, return total, when Python compiles this function, it says, aha, I have a and b, which are parameters. Those are by definition local variables. And total, we are assigned a total, and thus, that is also a local variable. And sure enough, if we look at CO var names in the code object, we will see a, b, and total, 3 local variables there. So if you assign to a variable in a function, it's local, even if there is a global of the same name. And that's because it's a separate, different bytecode. We use store fast. So if I say here, def of my func x equals 100, exactly what we had before. But now what's going to happen, you see here, store fast. This is a very different bytecode than we had before. Now this is fine overall, but what if we want to assign to a global from inside of our function? First of all, don't. But if you really, really must, then I will allow you to do it once a year and I will check. But if you really want to do it, you have to tell the bytecode compiler this assignment or this variable should not be turned into a local even if I assign to it. And so if I now say def my func, global x, x equals 100, the bytecode that's produced looks very different. Because of that global x declaration, we now have a store global bytecode. There is no local variable at all. It just stores directly to the global. So we've so far seen that the equal sign, the assignment operator, means 3 different things. Depending on the context, it can mean I'm going to assign to a global variable outside of a function, I'm going to assign to a global variable inside of a function, or if I'm inside of a function and I assign, I get a local variable. Well, let's make it more complicated. What about inner functions? Right? So we've already seen this, right? My sum, total, and so forth. What if I want to keep track of how many times I have invoked this function? So every time I invoke it, yeah, I'm going to get the total back, but I wanted to print out both x and y in the total, and I want to tell me how many times I've invoked this function. So one way I can do that is to stick this functionality in an inner function, and then the outer function will have a variable, a local variable counter, that will keep track of this. And this is how I can do it. I have def outer, counter equals 0, and then my inner function is basically what we had already, just it does a little printing. And what we're going to do is we're going to say, oh yeah, every time my sum, this inner function is invoked, we're going to say counter plus equal 1. So basically, I'm going to invoke outer, I'm going to get that inner function back, I'm going to call that inner function, and every time I call it, counter will go up by 1, right? So I'm going to say sum counter equals outer, and I call it, and there's just one little problem, which is it doesn't work, that I get an exception. And everyone has their own favorite exceptions. This is my favorite exception in Python. This is unbound local error. And what it means is, hey, you are trying to use this local variable before you gave it a value. No, but that's not what I meant. I meant to use the outer variable and assign to that. Yeah, but Python doesn't know that. And plus equal is assignment, not mutation. And as usual, if I assign to a variable in a function, that creates a local variable. So we want to assign a counter. That's outside. Maybe I should use global. Oh no, I can't use global because it's not a global variable, it's a local variable. I need to use the terribly named non-local keyword. And non-local means basically what we want to do. I say here non-local counter, and now when I invoke that inner function, the local in the outer scope will be incremented. And so I call here sum counter equals outer, I call it once, it shows that, yeah, we're doing this once. I do it again, and it shows me twice, and it works just fine. Well, how does that work? What's going on behind the scenes there? So if I look at the opcodes for that, we see that it's yet another opcode, store deref. And that's working in conjunction with copy free vars. We get the variables from the outer function, and then we store to them. So equal sign actually means 4 things. We can assign to a global outside of a function, assign to a global inside of a function, assign to a local in a function. We can also assign to a non-local in the enclosing function. Not bad. But wait, there's more. What happens here? If I say my list equals 10, 20, 30, and I say my list of 1 equals 999, is that assignment? Well, sort of, kind of, but not really. And actually in the Python world, no, we are not assigning, we are mutating. We are modifying the data. And that is different. It's very different because the variable still refers to the same data structure. It's the data structure that has changed. So let's go back to the Python tutor for a moment. If I have here my list, referring to that list there, and if I change this arrow on the left, that is assignment. It's changing which variable refers to which value. But if I mutate, I'm changing this arrow on the right. I'm saying what value is that list or is that list element pointing to? And so you know that it's going to look different behind the scenes with the store subscript, for subscript bytecode. That basically data here is my variable, and we're loading that up, and that is a local variable. And then my store subscript is storing to 1, and the value we're storing there is 2. Again, different codes. So now equal sign means 5 different things. We can be assigned to a global outside a function, assigned to a global in a function, assigned to a local variable in a function, assigned to a non-local variable in the enclosing function, or we could be mutating a value, typically a list or a dict, or maybe even your own object, on the left with square brackets. But there's more, because Python actually has 2 separate storage systems. It has variables and it has attributes. And you can think of attributes as a private dictionary, because it's a dictionary, on each object or on each value. So when you say a.b, what you really mean is the attribute b on object A, and A here is a variable referring to an object. And so how do we distinguish between these things? Variables live in namespaces. They're on that sort of left side that we saw in the Python tutor, but attributes live in the values on the right side. So can we assign to an attribute? Of course we can. It's Python. We can do almost anything. So basically, I can assign to an attribute on nearly any value in the language, aside from some like core compiled stuff. So I can take a module, import random, random.x equals 100, and there we go. I've added a new attribute to the random module. Well, what's going on there? Well, if I put this inside of a function, random.x equals 1, 2, 3, 4, and we do the this.dis, and we see that there is a separate bytecode for that, store adder, and we are storing to an attribute on a particular value. So actually, equals means 6 different things. We've got the global outside a function, global inside a function, local inside a function, non-local in the enclosing function, mutating data, or assigning a new value to the attribute on the left. And this is where things get really, really wild and crazy. So I'm glad you're sitting down. Because some attributes are special, and we call these properties. And basically, when we set them, we're just doing assignment, right? When we assign to them, a method is called. And when we read from them, a method is called, without parentheses. And it's a general rule of thumb that in Python, if you don't have parentheses, a method is not called, or function. And if you do, then it is called end of story. But no, actually, here we've got a slight distinction. So this is a simple property. Let's say I've got a car class, and I want to make sure that people can't just sort of set the speed to be anything. So what do? Well, I say self.underspeed. I'm going to have like a hidden private attribute there on the object. That's going to be set to 0. And then when people want to retrieve the value of speed, then they do so with speed. And I set with the property there, property decorator. But then I use this super weird looking decorator at speed.setter over a method of exactly the same name. I define speed again with a different signature. And now, basically, when I retrieve from this attribute, one thing will happen, that method will be invoked. And when I set the attribute, that method will be invoked, which is why I have print in there. So let's now create a car, right? C equals car, great. And I ask for the speed attribute. And look at this, it runs the method in speed getter, gives me 0. Then I assign c.speed equals 0, and once again, it invokes the method. And I say, what's c.speed? And now it has actually been updated. This is super weird, right? How can this be? I assigned to an attribute and a method was invoked? Maybe the bytecodes are different. So I say def set speed, c speed equals 100. We look at the bytecodes with dis.dis, and actually it's exactly the same bytecode, store adder. Same thing is going on. So what's happening there? And the answer is magic. Attributes have some magic. That basically, if a class has an attribute, so it's a class attribute, and that attribute is a property, and we assign via the instance of that class, then we invoke the property setter method. But that's the simple version. Because actually, that is a specific simple version of what are known as descriptors, which are sort of the deepest, hardest to understand part of Python. So I'm glad we have about 10 minutes. So basically, a property is a simple version of descriptors. And the descriptor protocol overall says, we define a descriptor class, basically like a property. And that class has dunderGet and dunderSet methods. OK, that's over there. We define an owner class, and that has a class attribute that's an instance of the descriptor. And if we then assign to the descriptor via an instance, again, it's a class attribute, we're accessing it and setting it via the instance, then the dunder set method is invoked. So, for example, here's my descriptor class, which basically does what my property did. Well, here it's just going to say things, right? So my descriptor, it has a value, it has a dunder get, it has a dunder set, and this is what will be invoked, including the printing, when we set via an instance on that. So I say here, very simply, class owner d equals descriptor. So d is an instance of descriptor. And I say o equals owner, right? So this is a class attribute instead of descriptor. And now I say o.d equals 20. What's going to happen? Well, o is an instance of owner. D is a class attribute on owner. We assign to d via the instance o. D is an instance of descriptor. The descriptor has a dunder set method. That method is invoked. And sure enough, when I say o.d equals 20, it does the printout. Let's make it easier and show it in the Python tutor. OK, maybe it's not that much easier. Fine. But you can see that we have three objects here. We have the descriptor, we have the owner, and we have the instance of owner. And we can see, basically, that it's still a class attribute. Let's make this a little more concrete. So instead of descriptor, we'll call it speed. And instead of owner, we'll call it car. Instead of d, we'll call it speed, lowercase. We just recreated our property, but now we can use it in multiple classes. I won't need to say at property again and again and again. So now my speed descriptor looks like this. And it's going to do the same thing as we had before, but sort of in rawer terms and lower level terms. So my dunder set here is going to get whoever the object was and the new speed, and we're going to check it and raise an exception if we need. And so now what I do is I say, here's my class car. Speed, again, class attribute. Class attribute speed equals an instance of speed, right? So then we have this here. And it actually works until we have more than one car. Because if I say car1 equals instance of car and car2 equals instance of car, they share that speed descriptor because it's in the class. And so basically, because the descriptor speed stores it in its own self-value, so assigning to car1 speed changes the car speed under speed, which means that it affects the second car. And changing car2 also changes it. That's probably not good. Right? And we can, well, we don't have to worry about this. It's just going to confuse things. So the solution is, don't store a single value in the speed descriptor. Instead, use a dictionary, right? We love dictionaries. So the keys in that dict are the instances of car, or whatever class we're using. And the values are the specific values for that descriptor. So when I say here, self.values equals a dictionary, and then when I assign not to the value, but self.values of whatever object it is. And when I set, I'm going to say self.values object equals new speed. And so now if I assign to car1.speed or to car2.speed, they are independent of one another. We're assigning to a class attribute via the instance. And the class attribute has a dunder set. And self is the instance of speed. Object is the instance of car. New speed is right on assignment. And the effect is to mutate, there's that word again, the dict in speed.values. It actually works. Yeah, except for one little thing, which is memory leaks. Because if you do this, you will have a memory leak, because the dict will always refer to all of our instances. And if it refers to our instance, then there's a reference. And if there's a reference, then the garbage collector won't let it go. So what are we going to do? The standard solution is to use a weak key dictionary, meaning that the key does not add to the reference count. And so if this is the last reference to that object, then it's freed up. So actually equals means 7 different things. We've got the global variable assignment. We've got global variable from a function. We've got local variable. We've got a non-local variable. We've got mutating the value. We've got assigning a new value to the attribute on the left. And we cause the dunder set to fire if we assign to a class attribute via an instance. And these are the opcodes that can be invoked if this actually happens. So, that's not what, oh, I don't, okay, fine. One or two other things. What about multiple assignment? By the way, never do this. But if you say x equals y equals 5, what's happening there? And actually, what happens is Python copies it and then does store fast, meaning basically it's a new opcode that sets 2 things at a time. So what if I say x equals y equals z equals 5? Is there a store fast, store fast, store fast? No, actually, what it does is it copies it again, and then does store fast once and then twice. What about unpacking? Right, x comma y equals 10, 20. Well, in that case, it actually says, oh, I have to unpack the sequence. It notices that it's doing unpacking, and then again says store fast, store fast. And with 3 elements, the same sort of thing. It'll unpack sequence 3, and then it will do store fast for 2 of them, and then store fast for the 3rd, and it's done. So, in conclusion, assignment seems really obvious and simple, but this one operator does a ton of different things. It creates variables and binds their names. It creates attributes and binds their names. It mutates values. It fires methods behind the scenes in properties and descriptors. And if you're not careful, it can even cause memory leaks. These different things feel similar to us as people, but Python sees them as totally different, as we've now seen from behind the scenes. All right, I think we have time for a few questions. Thanks very much.
Thank you, Reuven. Are there any questions? Yes, there are. So nice.
Yes, so I have one question. Since you had earlier this example like x equals y equals something, how does it work if y is, let's say, a dot b? Does it immediately assign to both, or will it basically assign to a dot b, and then if a dot b is a property, triggers the get method of the property to assign to x?
So you're saying a dot b equals?
No, x equals a dot b equals 1, 2, 3.
Oh, well, I think what's going to happen then is, yeah, it's going to copy that 1, 2, 3, and then it's going to assign. But it'll need. I hadn't tried that. That's a very interesting point.
Yeah, because
it will have to use then 2 separate byte codes.
Yeah, because usually when writing code, I tend to put then the a dot b on the leftmost side because I think that's probably cheaper. But I think you could come up with a reasoning for each way it would work. So
Yeah.
I thought maybe
that's super cool.
you or somebody knows how it actually works in that case.
Very neat. Thanks. Yeah, I'm guessing that's what it'll do. Yeah.
Hi. Thanks for that interesting talk. So I noticed that when doing x equals y equals z equals 1, it first does a single store fast and then does the store fast. While if you do the unpacking, it did a store fast first and then the last store fast. Is that deterministic, or like why is that different?
I'm guessing it's deterministic. I don't know why it was done in that order. I don't know. I didn't have time to sort of play with what happens if you have like s comma splat y comma z equals like what it's doing there, and like when you move it around. I have to hope and assume that the core developers played with this enough and sort of optimized it. But hey, maybe we'll like knock another 5% off the speed of Python.
All right.
Yeah. Well, thank you for the talk. It was very, very refreshing. You've been talking about classes and assigning and all the stuff. Given that recently, quote unquote, we have this data class decorator on classes, and there's a new syntax for how to do classes and how to instantiate it. Does any of these data class stuff changes, optimizes, and all of that, or it's just a wrapper around the class and eventually the class becomes something and all this stuff?
Yeah, it's just a wrapper. Like, I mean, I haven't gone deep into it, but basically when you define a data class, you're defining class attributes and the decorator sort of notices the class attributes and then writes methods. But the so it'll still be one of those attributes.
It becomes a normal class. It's just that most of the syntax is like probably hide from us, right?
That's right.
Okay.
That's right.
Thank you.
Okay, thank you very much. It's pretty much the time we have, so please give Reuven another round of applause.